Today's lesson is on inverse functions and relations. By the time we are finished today, you should be able to graph a function and its inverse, and you should be able to find the inverse of a relation or a function. The first thing is to remember what an inverse relation is. It's when you reverse the x and the y values, or y equals x symmetry. Our first example, we're going to graph y equals f of x equals x squared and the inverse f inverse of x. Notice the notation for f inverse of x. It just looks like f to the -1 power of x. That is read f inverse. First, I'm going to find the values for f of x when f of x equals x squared. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Graphing those points on our coordinate plane, we end up with a parabola. And it looks just like that. Now remember what we just said about the fact that inverse functions have y equals x symmetry. There are two ways to graph the inverse. One would be to just simply reverse the ordered pairs. We're going to do that first, but then I'm going to point out the symmetry to you as well. If I reverse the ordered pairs, what was x now becomes, what was y becomes x, and what was x becomes y. So our first ordered pair, instead of -3, 9 is 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, and 9, 3. So we end up with a graph that looks like this. Now to demonstrate the y equals x symmetry, if I were to put in the line y equals x, hopefully you can see how the points match up. The point at -1, 1 matched with the point at 1, -1 across the line. The point at 1, 1 matched on that axis of symmetry. The point at 2, 4 matched with 4, 2, and so on with the remaining points on the graph. One of the things we need to be able to determine is if a function's inverse is also a function. Sometimes they are, sometimes they aren't. And if you remember, way back in the day, we had what we called the vertical line test for functions. Now, to go back and just look at the original function, we're just looking at the red function right now. If we were to do the vertical line test, what we would do is take a vertical line, pass it through the function, and notice that at no place is there ever 2 points on the same x value or the same abscissa. Now, if you notice when I'm going through the inverse, can you see how the inverse fails this vertical line test? This is a circumstance where the inverse is not a function, but the original graph is a function. Now, without graphing the function, I would have been able to determine that, again, just by looking at my original graph. Since the inverse is when it's flipped over y equals x, if we just change the graph around of our line to a horizontal line instead of a vertical line, we can do what we call the horizontal line test on the original function. Now, if you're looking at the original function, you can see that on the original, it crosses in 2 places. This means the inverse is not a function. All the horizontal line test does is it gives you an opportunity to test the original function instead of graphing its inverse before you check. This page is for you to try out. See if you think these are functions or not using the vertical line test, and then go back and use the horizontal line test to determine if its inverse would be a function. Try this now. Pause the podcast and try it now. Let's check your work with the vertical line test. Here comes our vertical line. As it's passing through this graph, this relationship, I can see at this point that the original graph is not a function. That hasn't answered the question about the inverse, though. I need to see if the inverse would be a function. So to do that, instead of regraphing all of those points, I'm just going to come along with the horizontal line test. And as I do the horizontal line test, I can see that nowhere on this graph are there 2 points on the same horizontal line. Therefore, the inverse is a function, the original is not. Original, not a function. The inverse is a function. Looking at the next graph with the vertical line test, we pass. So the original function is a function. Going back with the horizontal line test, we can see that it fails. So the original is a function. The inverse is not a function. Now, here's hoping that you didn't get tricked on the next one, because on the next one, they are actually both functions. Most people can see the vertical line test because you can kind of see that that graph is still going up more of at an angle. It's not going completely vertical. The horizontal line test is where people get a little messed up, and that happens right here. And why that happens, it happens because of the pixels on the calculator. This was a calculator-generated graph, so it was very difficult to tell at this point. But the graph actually is a little bit more slanted than that. It looks a little bit more like that if you were to graph it in real life. So they are both functions. This one is actually the graph of y equals x cubed minus 3. Now, the steps at the bottom of the page are just telling you how to find the inverse of x algebraically. This is a review from Algebra 1 and Algebra 2. You rewrite using y notation. You switch the x and the y. You resolve it for your new y, and then you rewrite it in function notation. So let's come over here and look at an example. I'm starting with the function of f of x equals x squared minus 4. So the first thing I do is I rewrite it, and instead of f of x, I fill in y. My next step is to switch the variables. Where there was a y, there's now an x. Where there's an x, there is now a y. Now I'm going to solve it for the new y. And when I solve it for the new y, I add 4 to both sides. Then I take the square root of both sides. This is where people have a tendency to mess up, because when they mess up, what they do is they forget that when you take the square root of a variable, you get both the positive and negative answer. So the actual answer is y equals plus or minus the square root of 4. In order to graph that on your calculator, you would actually have to enter it into 2 separate y equals equations. One, the square root of x plus 4, and one, the negative square root of x plus 4, in order to see the entire inverse graph. If you look at the original graph, it's y equals x squared minus 4, which hopefully at this point we all know is a parabola that has been shifted down 4 places. And you should be able to tell by looking at this that this graph would fail the horizontal line test. So therefore, the inverse is not a function. The next thing we're going to look at is composition of functions. You had this back in Algebra 1 and Algebra 2 as well. It was either written f of g of x in this first notation, The other notation is f in this little circle right here for of g of x. I always like to call them fog and hog and goff and hoff. They always use f, g, and h for functions. Now our first function is f of x equals 2x plus 3. My second function is g of x equals 4x minus 1, and I'm going to combine those functions using a process called composition. The first one I'm going to do right here is f of g of x. What this means is whatever is in here is going to go inside the parentheses. So g of x goes in the parentheses. Here's g of x. Notice how I put that in place of f of x. Now, what f of x means is everywhere there's an x in the rule, you fill in whatever is in the parentheses. So notice it was 2 times x, so I did 2, and then I filled in what was in the parentheses, which was 4x minus 1. After this, it's all arithmetic. Distributive property, 2 times 4x was 8x, 2 times a negative 1 was a minus 2, and then the plus 3 is still part of the problem. So the answer for my composition was 8x plus 1. Now, determining if things are inverses or not can also be done with composition of functions. If f of g of x gives you exactly the same answer as g of f of x, and that answer is x, then you know the functions are inverses. So we're going to determine if 4x minus 9 and x plus 9 over 4 are inverse functions. So the first thing I'm going to do is I'm going to do f of g of x. That means I'm going to do f of x plus 9 over 4. Meaning I'm going to take this x plus 9 over 4 right here, and I'm going to put it in the f rule everywhere there's an x. So when I substitute that in, I get 4, and now I'm going to fill in the x plus 9 over 4, and then I have minus 9. Now when I do this work, the 4's will cancel. I get x plus 9 minus 9, which is x. That means that it's still possible for these two things to be inverses because I got x for the answer. Now I have one more problem to check, so I have to do g of f of x. So I'm going to do g of whatever f of x is. And f of x happened to be 4x minus 9. So I'm going to take this 4x minus 9 and I'm going to substitute it into the g rule. When I do that, I'm going to get 4x minus 9 plus 9 over 4. Notice I filled in the 4x minus 9 where the x was in the g rule. That gives me 4x over 4, which is x. Check. Check. These are inverse functions. That concludes the lesson on inverse functions.